what's really going on inside of a proton collision? Is there a Higgs boson secretly hidden inside the proton? Or maybe there's some dark matter in there. If we hit it hard enough, it'll knock the dark matter off. That's not what's happening. What happens with a proton collision is actually the two protons get close enough so that they can feel each other with a certain force. Because that question that we asked earlier, when you're asking, how small can I cut anything? You're secretly asking, what was holding anything together to begin with? And the thing that holds things together at the particle level are forces. But at the particle level, forces are mediated by other types of particles. It's like a force exchange. So it's a little bit strange for us, humans. We're big, bulky humans that evolved in this, on the surface of the Earth in this certain energy range, and we can't really intuitively understand the quantum world. But the quantum world is a bit odd. So, but one way you can, as an analogy, you can do it is, for example, you can get a sense of it is, you imagine you and your friend were on an ice skating rink. Okay, and you're both standing right in front of each other. One of you has a gigantic ball, like a big rock or something like that, and you throw the rock to your friend. As you throw the rock, it's really heavy, so you're going to slide backwards, right? And as your friend catches it, she's going to slide backwards as well. So in a sense, we have just exchanged a force-carrying particle. That's the way particles interact. But particle collisions are weird compared to what we think of as collisions in our everyday life, because if you were actually particles in the quantum world, you and your friend actually have another option for when you throw the rock. You can not just throw the rock to each other. The two of you could actually smack together and become the rock. Perhaps let's use a different analogy. Particle collisions are not like car collisions. We like them to think so. We like to think of that in a way, but they're not like car collisions. They have different rules. When two particles collide at almost the speed of light, the quantum world takes over. And in the quantum world, two particles can actually cease to exist, and a new particle can be created in their place that lives for a tiny fraction of a second before then splitting into other particles that hit our detector. Imagine a car collision where the two cars vanish upon impact. A bicycle appears in their place, and then the bicycle explodes into two skateboards that hit our detector. Hopefully not literally, but this is the sort of thing this is a bit of a weirdness that happens at the quantum level. So the way that's possible for that to happen is that go back to your high school physics. I hope I'm not going to scare anybody off by saying go back to your high school physics. Go back to your high school physics. What does physics really care about? Physics doesn't care about the names of things. It doesn't care that this is called an electron, and this is called a positron. We care about that for car collisions. Is Mary okay? Is Jack okay? But particle collisions, they don't care about that. Physics cares about conserved quantities. I hope I haven't made anybody fall asleep just by saying those words. Physics cares about conserved quantities because you think about what it is that the conservation of energy, conservation of momentum, conservation of charge, and some more arcane ones, conservation of spin. These are the things that particle physics cares about. So as long as I conserve these things before and after a collision, I'm all good. So here, for example, this is a diagram. I hope I haven't scared anybody off with a diagram. This is a Feynman diagram. Maybe Richard Feynman. But on the left-hand side, you have two quarks coming out of the proton in one of our collisions. Two quarks. At some point, they're far apart in space. They get closer and closer together, and at some point, they annihilate. They cease to exist, and then a Z boson appears in their place. And then the Z boson lives for something like 10 to the minus 12 seconds, basically nothing, and then it splits into two muons. That's crazy. You started with two quarks and ended up with two muons. How is that even possible? And so this is what we do to look for new particles, because the thing we care about is that middle part, the Z thing.